So, now talking about the octet, and it's called the octet not because of its shape, obviously, because there's 8 particles associated. And these are all hadrons. None of these are antihadrons. You can make another octet using the antihadrons, but these are all just hadrons. Okay? So, what I have here is most important thing about this is my neutron and my proton, composed entirely of generation 1 particles. You know that the charge of a proton typically is +1, the charge of a neutron is 0, and it has a spin of 0. Now what does that mean? I thought we determined that the neutron and the proton have a spin of 1/2. Well, the spin of 0 is just meaning that it's at base. Okay? The base level for spins is 1/2. And then we're moving down, I guess, -1, -2, when we're dealing with these other bits of configuration. Okay? We're dealing with different particles and different configurations, which are giving me a different spin number. Cool? But the most important thing is knowing the location of the neutrons and the protons on the octet for the hadrons. Okay? Other particles, we have a lambda, we have a sigma, we have some particles down here. But the most important is proton, neutron. And like I said, these are only positives. There's no antiparticles represented here. We could have antiparticles. We could see a negative proton, but it's not represented. These are all real quarks. These are all particles that are composed of real quarks. Okay, no antiquarks. I guess those are real too. But nevertheless, okay? So I just wanted to briefly show you what the octet looks like. Now there is another octet for mesons, and I'll show that to you in a second. But it's not really an octet because there's more than 8. Okay? Cool? Got it? So, most important thing, they ask you to locate the neutron and the proton in the octet. It's your top. Okay? Cool.